All right, so today we are going to be learning how to use this quadratic formula. You've hopefully spent a little bit of time trying to remember it and learn it from the song. But how do we use the quadratic formula? So first of all, in order to use it, you have to put whatever quadratic equation that you're using into standard form. And standard form means that we have to put it in the order of starting off with the quadratic term, which is the x squared term, then the linear term, which is the x term, and then the constant term, which is the term without any x in it whatsoever. It needs to be in that order, that standard form. A is the coefficient of the quadratic term, B is the coefficient of the linear term, and C is the constant term. So let's figure out what are A, B, and C for this equation right here. First of all, we need to get it into standard form. So let's move all of the terms to one side of the equation in order, and then get 0 on the other. Okay, so when we do that, we are going to, and we need to get them all into the order, the quadratic term, then the linear term, then the constant term, and we have 0 on the other side. That means A is the coefficient of the x squared term, which is 2. B is the coefficient of the linear term, which is 9. And C is the constant term, which is negative 18. So now we're going to plug these into the quadratic formula. Where there's a negative b here, we're going to plug in a negative 9. That's where we get that. Where there's a b squared, we are going to put in 9 squared. Then we have minus 4, so we actually write in minus 4. And then a, which is 2, c, which is negative 18. And this is the part where people mess up the most here. I will with the sign, so just be careful of that. And then all over 2a, so 2 times the 2 here in the bottom. And then it's just simplifying using the order of operations. But again, this part here, where this part is under the square root, is where we're going to simplify first. This 9 squared, if it was a negative number being squared, it is also going to come out positive. So just be careful. This b squared is always going to give us a positive value, because whether it's a negative or a positive and it's squared, it's going to be positive. However, this is where people mess up the most with a minus 4ac. We have a negative times a negative. Anytime we have an even number of negatives, we're going to end up with a positive. If we have an odd number of negatives, we're going to end up with a negative number here. And so when we multiply this through, we get 81 plus 144. Add those two together, we get 225. And now, going on to the next page, just ran out of room. This does take, it's quite a few steps to do this. Now we're going to actually take the square root of 225, which is 15. And here's where we break it up into the plus and the minus. Remember that there's a plus and a minus in the quadratic formula because there's two different solutions, two different roots. And by the way, when we're solving these, the solutions to this, oftentimes the word for quadratics that we use are roots. Roots and solutions means the same thing in here. So to find the two roots or two solutions, we write minus 9 plus 15. There's the first one, and the other one is with the negative. Minus 9 minus 15. We get 6 when we add the negative 9 and 15 together. We get negative 24 when we add these two together here. And then 6 divided by 4 is 1.5. Negative 24 divided by 4 is negative 6. Okay, so we've gone ahead and solved that using the quadratic formula. So why couldn't we have just factored this? Couldn't we have just broken this into its factors like here and then set them both equal to 0 and solved it like when we learned how to solve by factoring? Aren't we going to get 1.5 and negative 6 when we do it that way? Yes, in fact, this is the same problem we did earlier by factoring, so we could actually do it the other way. We are learning different techniques to do the same kind of work, and for different types of quadratic equations, sometimes one is easier to use than the other. Oh wait, well, didn't we also learn how to complete the square? Couldn't we have just done the completing of the square? Yes, you could, absolutely. We could do this using completing of the square. As you may have noticed in the videos as we were doing those, though, sometimes it's a little bit complicated in terms of what we're adding onto each side. And it's not the easiest way to do it, but yes, you can do this with completing the square, and we will get the same answers: x equals 1/2, x equals negative 6, using that method that we learned from James Tanton on his videos. Okay, Couldn't we also have just graphed it? Wouldn't it, we've just graphed y equals to, once we get it into standard form, set y equal to that, throw it into the Desmos, and find out that the x-intercept, one of them is at -6, the other one is at 1.5, right there. Couldn't we have done that? Absolutely. There's another way of doing it. We are learning a lot of different tools to be able to solve quadratics. Okay, but let's get a little practice using the quadratic formula. Go ahead and solve this one using the quadratic formula. If you get a little bit challenged here with what's under the square root, you're going to get a negative under the square root. And if you get a little bit lost at that point, that's okay. Then just click continue, and we can help finish it once you get that. But go ahead and start it off until at least you get the square root of a negative number, and then we'll try to deal with that in just a little bit. So hopefully you got far enough down realizing that a negative times a negative times a negative is a negative number. And when we took 4 minus 40, we got negative 36. And then we said, uh-oh, wait a second. I don't know how to take the square root of a negative number. In fact, that's impossible. If you took the square root of positive 36, it would be 6. That's because 6 times 6 is 36. But what times itself is negative 36? There is not a single thing in the world that times itself is going to give me negative 36, because a positive times a positive will give me a positive number, and a negative times a negative will also give me a positive number. This is not possible in our real number system. So what mathematicians have realized is actually these numbers are still useful, but we've developed another number system to help us take care of this, and it's called the imaginary number system. And if you're like me, when I first heard of imaginary numbers in math, I was actually like really angry about this. I was like, oh my God, math is hard enough to like with the real math, to let alone having to make up stuff imaginary. And technically, it's not really made up. And in fact, imaginary numbers probably not a great name for it. But the reality is it does not fit into our real number system. And so in this particular case, we know the square root of 36 is 6. But the square root of -1, by definition, we call it I. You don't have to. You're going to do a lot more of this in Algebra 2. You don't need to know how to find the imaginary roots in this class for this year. But you do need to understand that we are going to get an imaginary number. Now, if we have 2 plus or minus 6i and divide that by -2, then we are going to get 2 divided by -2 gives me -1, and 6 divided by -2 gives me 3. So we get -1 plus or minus 3i. The first part, the -1, is considered the real part of the answer. The 3i is considered the imaginary part. Together, the two of them make up what's called a complex number. And sometimes the word complex numbers and imaginary numbers are used interchangeably, but just know that the answer to this quadratic are 2 imaginary or 2 complex numbers. That's the important thing to know. And that is very different than getting 2 real numbers as your answer. So we just learned that the solutions to this one are imaginary. Then what are the x-intercepts? I'm going to take the same equation here. Instead of having it equal to 0, I'm going to set it equal to y. If I graph that, we learned that the x-intercepts of this equation should be the same as the solutions or the roots to this equation. So where are the x-intercepts? If the x-intercepts are imaginary, where does this graph cross the x-axis? And the answer is it doesn't. If it were real numbers and it crossed the x-axis, we would have real answers. This parabola here never crosses the x-axis, so we know that if we get imaginary solutions to this, that it means that this graph will never cross the x-axis.